Hello, it's me Vince, and welcome back to the final speedrun of day 6. It's been a long day. This is the ninth speedrun, and so finally we will be finishing chapter 2.2. So, what are we doing now? The final exercise involves piecewise functions. And piecewise functions are functions that are defined a certain way for a certain domain and a certain way for another domain. And we've already met one. It's the absolute value function. So for absolute value, y is equal to, well, x for x is greater than or equal to 0, and negative x for x is less than 0. But we can also define our own functions like that. And I guess the best way to explain piecewise functions and how they work is to jump into some questions regarding them. So I'm going to be doing even questions. Again, I feel like even questions. So the first question is quite a long one. That's what it is. So we have y is equal to, and then first we have 4 minus x squared for x is greater than 0. And we have x squared for x is less than or equal to 0. So the first question asks us to find the function of -4, the function y when x is 0, and y when x is 1. So when x is -4, we use this x squared because x is less than or equal to 0, which would be 16. When f is 0, we do the same, so this would be 0. And when f is 1, we use this top one because x is greater than 0. 4 minus x squared would be 4 minus 1, which is 3. So that was pretty simple. Next, we need to sketch the function. So just sketching roughly. If it's greater than 0, then what they're saying is they want it to be 4 minus x squared, which looks something like this. But if it's less than 0, then they want it to be x squared, which looks something like this. So this would be a rough sketch of the function. Finally, we need to write down the domain and range of the function. So because all bases are covered, x is greater than 0, x is less than or equal to 0, we can say the domain is equal to just x is a real number. And for the range of the function, well, we can see that it actually covers all ranges. So I think the range will also be when y is equal to a real number. Now, let's just check if that is correct. And yeah, that is correct. So they're both just when y is equal to a real number. And so now, for the final question of the speedrun today, well, first we define a function as the absolute value of x plus 1 when x is less than -1 should be absolute value. Otherwise, it is the square root of x plus 1 for when x is greater or equal to -1. So we need to find the function of -1, the y when x is 0, y when x is -4, and y when x is 8. So when x is equal to -1, we would use this equation. -1 plus 1 is 0, so the square root of 0 is 0. When we're inserting 0, again, we use this because 0 is greater than -1. 0 plus 1 is 1, square root of 1 is 1. For x is -4, we would use this top one. So because -4 is less than -1, so we have -4 plus 1 is equal to -3. And for 1 is equal to 8, well, we would use this one here. So we would have 8 plus 1 is 9, square root of 9 is 3. Simple. Next, we need to sketch the function. And if, I think I've been sketching a lot of functions in these speedruns, and if you're not too sure how to sketch a function, I would highly recommend going online and looking at what some functions look like, because you need to know your basic function types. You need to know that absolute value looks like that. You need to know that quadratic functions look like that. You need to know that cubic functions look like that. Linear functions look like that. Square root functions often look like what would be an appropriate square root function, something like that, and so on. So in this case, sorry, we're sketching a function. So when x is less than -1, it's equal to the absolute value of x plus 1, which looks like x plus 1 looks like this. And when x is greater or equal to -1, we have the square root of x plus 1. And a square root graph looks something like this. So this would be the sketch of our function. Yeah. And finally, we want to write down the domain and range, or state the domain and range. Since we have all values of x covered, we can actually say that the domain is when x is just part of the real number set, but the range is otherwise, because as you can see, the function never goes below 0. So we can say that our range is simply y is greater than or equal to 0. Yeah, so that's all for day 6, completed speedruns. I hope you like the speedruns, I hope you're enjoying them, and I hope you continue to follow along to learn some more math along the way with me. See you in the next speedrun tomorrow.